you will see multiple systems, um, and you need to fit your ERP in there. There are always integrations. So when you go as an integration architect or a technical architect, your first job should be to ask these questions, like what is the frequency of it? Like how frequently you want to run, like every hour, every 30 minutes, every second, what is that? And then question why is that, right? Always question that. Uh, what's the volume? What's the peak time volume, like during the Christmas time, during the Thanksgiving holidays, or if there's any other, cultural season or cultural, time in any region, in any country where there is a, you expect a lot of volume, then always talk about those questions because organization knows that. They know the volume. If they don't, they will go and figure this out for you. What is the average volume, like day to day? Generally, if I sell 1,000 pair of shoes every day, for example, uh, yeah, I mean that's the average volume. But maybe during the Thanksgiving time, I may be selling 3,000 or 4,000. So that actually puts the load on the system. So that is peak time volume. And then also try to talk about what are the peak time hours. For example, is there a particular time in a day where you see most number of orders, right? Or is there a particular time of the day where every employee submits its timesheet, right? Or submits its expense report, right? So talk about those things so that you can kind of gauge that, okay, during those particular hours there will be a load on the system, and that would be the total volume. One size does not fit all. So always keep in mind while analyzing an integration problem that, whatever design you come up with, that may not solve all the integration problems, right? So it depends pretty much on the first bullet. Once you ask these questions about all the integrations and kind of record it in a spreadsheet, then you may think about, okay, where you have a synchronous problem or where you have an asynchronous problem to solve. And this would actually help you to kind of identify some of the common uh, ways to solve that problem. So always think about that you cannot use, for example, Azure SQL for all the integrations, or you cannot use Data Lake for all the integrations, right? Just to be more specific. And design for some common data elements. Same concept. Think about. Let me be more specific in terms of FNO. So think about what can you reuse, right? Like if a if I give you an example, let's say in ERP you are maintaining products and inventory, right? And uh, product is something which is needed by your e-commerce system, your B2C system. Product is something which is also needed by your B2B system. Product also needs to be shared with your retail system. Suppose if they're not running FNO retail, if they may have their own retail system. So the product needs to be synchronized to all these systems at some particular time because your book of record is in ERP. So uh, can we build a common product entity? Or can we use an existing product entity, product master entity? If we can have a common product entity, can we use that not just for exporting data, but also importing data? Ask those questions. Uh, can we also use that product entity as an audit endpoint, right? So this way you could have a very, uh, concise list of objects to think about. And I know that this is not the case 100% of the time, but at least you can try that. Try to have a common object and reuse it in multiple integrations. So these three bullets to me, that helps me a lot to kind of continue to come back to it, try to find out common grounds, and then build an architecture. Some of the, if you guys are familiar with FNO or formerly AX, these are some of the options that we have available in FinOps for integrations. And I just put them in different areas. So if you have synchronous, means real-time requirement. You want data to be synchronized with the other system right away. So these are some of the options. And similarly on the asynchronous side, which is, some system might need data uh, overnight or maybe every hour. Those kind of requirements are asynchronous. So we have, data management framework jobs. We have BYOD and data lakes where you can export data to an outside system. We have recurring integration, all of those things available in Dynamics that can be configured. Okay. All right. So moving into, so I'm kind of building the foundation before we actually talk about some design patterns. So uh, on the same note, here although there are so many services, technologies available in Azure or Microsoft Cloud to use, and there are a variety of reasons, but since we are just focused on integrations with FNO, so I find these 5 things very helpful, very useful in many integrations that we build. There may be many. Someone can say, hey, why don't you use Azure Data Factory for this and that? And oh yeah, that's great. We can. It depends on different scenarios. It's all about building integration between the two systems. If we have, for example, if you ask me, hey, how about the data warehouse? How about the analytics? Yeah, then I would just use probably BYOD to sync the data out to Azure SQL or Azure Data Lake in future, and then kind of use my BI reports on top of it, right? So that is more of an analytical problem, right? But if we talk about communicating between the two systems, that's, to me, it's more of an integration problem. So logic apps, everybody knows what it is. Function apps. We're going to quickly dive into these technologies real quick without taking too much of your time. Um, Logic apps, if you're new to it, it's basically workflow-based design. It allows you to uh, kind of design your flow in a workflow fashion. It supports so many connectors and different programming constructs like conditions, loops, things of that nature. Uh, it does have triggers and actions, so you can trigger integration on a particular event, if you will, and can add some action on top of it. It's easy to design and maintain. You can even build it in Visual Studio and deploy it using ARM templates. So that's one piece of it. The second piece is, to me, is a function app. Um, we can also use function app and logic app interchangeably, but I find function apps more uh, helpful in scenarios where you need more flexibility, right? You need more uh, something that you want to do in the code, right? As a programmer, if you are a programmer or a developer, or if you have the same background as you'll find it much more uh, kind of flexible and find more control on different things, right? So you may have a requirement where you want to make decisions on certain data elements, and not just that, but also transform that data into a different format. So that's where I find it much easier, to write the code in. Um, it also supports web APIs, as I said. It can be built as a web API. So as Steve mentioned in the last session, we have API management, which is a separate piece in Azure. You can have your API management based APIs created on top of it, which is basically just a facade pattern. But behind the scenes, you need a place where you can actually execute your logic. So function apps is that thing. It's serverless. They are scalable. There are different tiers available depending on your need. You can sign up for premium tier and have it available always. It's on demand. It's cost effective. Also, I think first 1 million executions are free. And then after that, they charge very little. And it can tackle more complex scenarios. As I said, it gives you, the whole programming .NET framework on your disposal. It supports many languages. Like some of these are here. I think these are the only languages. Maybe they also support PowerShell. I'm not sure. But these are the ones that they support: C#, Java, Python, JavaScript, and TypeScript. And then you can make, as I said, you can build them as web APIs. You can secure them using standard OAuth 2.0 mechanism, like client ID and secrets, all of those things. Is there a question?
No. Yes.
Okay. Yes. Okay. Azure Service Bus queues and topics. So these are enterprise level messaging broker system. What it does is it allows you to store messages in a queue and then process them. It's available, as I said, it's in Azure. You have Service Bus, so they do support both queues and topics. It helps you to decouple applications and kind of use it as a messaging platform. It's enabled load balancing. We have two variations of it. One is message queue, which is kind of queue like you first in, first out. And then you have the concept of topics, which actually you push the message from a single source, but you can have a multiple receiver. And that's because, sometimes you have a requirement where different applications, just want to process messages in its own way. So that also gives you this flexibility. Like you have to just build these topics and then provide the endpoint information to the consuming application. We have Azure storage accounts. This is something that we also use quite a lot to store files in Azure. Blob storage, I think everybody's familiar of it for the most part. In FNO, when we attach a document or anything, that also gets stored in a blob storage, but that is a native blob storage of Dynamics. But you can also create your own blob storage account and move the files there. It's a very, I would say, cost-effective way to store files. It could store any kind of files, like small files, heavy files. Usually in ERP integrations, we have, mostly data in the CSV format or JSON or XML. Those are not super heavy, but it's a good way to, securely save the files. It does provide several file accessing mechanisms like REST APIs, and other Azure specific options to access those files. Other thing is, you can actually extend FNO, right? So you need to, if you want to, you can write some code to, programmatically upload files to a different blob location. And that's where, your logic app and function app can be triggered and do the job, whatever you want to do with it. At the bottom, there is a, kind of hierarchical architecture in terms of how the blob files are stored. Once you create an account, you can have containers in it, and then under the containers, you can have files. One more thing that we utilize is key vaults. Key vaults is a way to store. It actually does provide you some increased security, right? So you can store your sensitive data like passwords, keys, secret keys, or secrets for some APIs. Let's say if there is a third-party system that you want to access and you want to store that client ID and secret somewhere. So those are the things that can be inserted in here rather than you store them in a file or a database which can be read by other people, right? It's better to store that kind of information in a key vault, and it provides you a whole way of how to access them. There's this different access policies that you need to define, and the application, even if one application need to access that key vault or that key information, that application has to have a explicit access to that key vault. So it's more secured way of sharing that level of details. All right. So far we talked about some issues with the point-to-point integrations and why we end up and how we end up there. We also talked about some of the options available in FNO. We touched base on some of the Azure services that can help us to build integrations. So let's just see, okay, how we're going to solve that in a real world integration problem. So suppose we have a requirement where we have to synchronize some customer information from FNO to two other systems like CE or and like some other online store, maybe a Magento-based web store or Shopify-based web store, where you want to push the data in as soon as the customer is created. And this is a real-time requirement. So we know that in FNO, we have business events. Now, business events allows you to configure and push a message to a different to a service bus, basically. And there are a lot of other options like service bus queues and topics, and you can even have event grid, OData, and I'm sorry, not OData, some logic app. You can even trigger a logic app by just providing its HTTP endpoint. So several things it supports, right? It's a framework in FNO. So what happens as soon as something happens in FNO, that event is triggered if you configure it, and then it transforms. I'm sorry, not transform. It actually transports the data into a service bus. Now, there is a caveat, which is we should not send too much of data in the business event because there's always a limitation in there. So I would say send only what is needed. So in most of these cases, we don't need the whole customer record or whole vendor record. We just need, customer ID, first name, last name, and date of birth. Maybe not date of birth, maybe address. Some of the key fields. So if the requirement is that okay, you just need the target system needs only limited set of data, you can just use the business event to send it to the service bus. The function app will be triggered as soon as the service bus receives it. And then the function app can call a web API of these respective systems. So you can think about it as a middle layer, because now what we are doing is we are doing all of this is in Azure. Suppose in future, if there is another system added that also requires the same customer information, you can just update the function app to call that third system, right? Or if something that, let's say someone say that, hey, you know what, initially we are sending 10 fields through a business event. Now the third system requires another 2 fields. That's fine. You can still extend that same business event in FNO. I mean, we cannot completely avoid code changes, but the point is that we are building on an existing, common design pattern, common architecture, rather than creating another integration just for the third system, right? So that's the whole point. That's we need to think in terms of kind of middle layer approach. Another pattern. It is also synchronous, but the only difference is this time we are talking about inbound, right? Suppose the customer is being stored or created in CE. The book of record of customer is in CE, and then we have to sync it to an ERP system and an online store. Same thing, for CE, you can configure it as a business event. You can push it into, I'm sorry, not as a business event. You can push it into, you'll need to customize CE and add some integration, some plugins to push the data into a service bus, but the same architecture can be utilized there. The only difference would be on the FNO side that you will have to have an OData call. And that's where you need to also think about the volume and everything, like how many customers updates are happening per minute or per hour. And if it's too much, then OData may not be the right approach, and you may have to think about certain other options. Same way, this is also a middle layer kind of approach. You can build on top of it. All right, third pattern, asynchronous. So this is one thing that I want to emphasize on, is that if there is not a need of real time integration, then don't go with it. Then always design a solution in an asynchronous. Always, when you discuss it with your stakeholders, and if they're okay with it, then always go with an asynchronous solution, because that reduces client server chattiness, that reduces too much load from the FNO. And that's really kind of, I would say, scalable also, because if the data volume increases, you don't have to think about it. You can just utilize the same architecture for many number of years. So the idea here is that suppose you have FNO and you have some purchase orders. Every day we create some purchase orders. You have two systems that needs those purchase orders. One is freight forwarder system or freight forwarding system, where if you have international purchase orders, those orders goes out to a third party system, and then those are fulfilled by some international vendors. So those freight forwarding system requires you to sync purchase orders, but there is not a real-time requirement. It may be every 3 hours or every night, right? Depending on the business. Similarly, you may have a B2B portal, right? That is also depending on an SLA. They don't need it right away. They can wait. What you can do is you can build a data entity, or you can utilize an existing data entity, create a data project in data management framework, and build a logic app in the middle layer to export the data and push it into the freight forwarder system. Okay. Now, I'm not going into the specifics of what is the communication mechanism between, this system and our system, or maybe a logic app, because, freight forwarder may say, hey, just drop the file in a CSV format or in XML format, or we have a web API, just whatever it is, logic app can do it. It just need the, access details and some of the logic built into the logic app to do that. Similarly, if another system needs it, like B2B portal, so you can have another logic app with a different data project, so that, you can trigger it. So this will be in a scheduled logic app. It can be triggered on any scheduled time that would execute the data project in FNO, and we'll get the exported data in a data package, and then just if there is any transformation needed, that will be done in a logic app, and then push it into the B2B portal. So that's a high level, right? If you find that there's so much work that cannot be done by a logic app, you can change it to a function app. As I said, it gives you more control and more flexibility. For you, this is the middle layer. So if you can continue to add, more systems on the right-hand side, you can continue to utilize the same data entity, add additional data projects, and then add different logic apps or function apps in the middle layer to kind of do that job. I also wrote a blog some time ago. It's the URL is here. You can go and see what is it all about. it gives you all the step-by-step instructions on how to build that logic app. All right, demo. I do not have a demo ready. That's because the logic app is there, but the only thing is the system, the FNO system that I had, which I used, is no longer available. I deleted that system to save some Azure cost. So that's why I cannot run it, but I can at least show you how the logic app looks like. It's basically, starts with the scheduled. I just schedule it to run, for example, here every Monday at 10 o'clock. What it does is it just, call a system, call a data package API in an FNO system. That was the URL of my FNO system. And then execute that data package or data project, get the data package, and then once it's received, it actually created in a blob location. And if there are any errors, okay, I didn't do anything here. Yeah, if there's any error, then I wanted to send an email. I don't know if it's there or, okay, it's here. If there's any error, then it sends an email. Currently, every connection is broken because, as I said, the data, that system is no longer available to me. That's why I couldn't show it to you, but that's the whole design of that logic app. All right. So another asynchronous pattern. It's the same thing. The only difference is that in this one, we are actually dropping a file through FNO to a blob location, and then the drop of that file is executing or basically triggering a logic app, and the rest of the work is same. The only difference is that the control is on this side. We are controlling the schedule of the execution from FNO rather than in the logic app. That's the only difference. But for this, we'll have to do some coding, some extensions in FNO to kind of upload that file on a specific blob. That's the only change that we would require here, but that's doable also. All right. So, in the beginning, as I mentioned, when you start designing a system, when you ask questions, when you know about all the target systems, just ask these questions and try to identify the common points, and then try to build a diagram like this or something where you can identify a common patterns and also common building blocks that can be built as a separate piece of effort. And then can, especially in this case, as I can tell you that the middle layer is basically here, where we are utilizing different Azure technologies, and kind of this is kind of agnostic, like whatever system you kind of push into here, or you want to add it in future, right? So you will have some of the logic built into here if it's documented properly, and then you can kind of reuse it for different other integrations. Here, if let's say if the product master is required by B2C commerce, and if it's also required by B2B system, you can always communicate or collaborate with this with different stakeholders to determine, can we use the same architecture? Can we use a single service bus to push the data into both the systems, right? So this way, everything, whenever you add a system, you don't have to build a complete new integration. You will have some work done already, and you'll need to build just the endpoint in the middle layer to communicate with that system.